Namaskar, welcome to CEC Gurukul Lectures. I am Dr. Kumar Shantanu, Associate Professor of Botany from Deshbandhu College, University of Delhi. In this series of lectures on basic laboratory equipments, we have already covered some of the very frequently used but basic laboratory tools such as weighing balances, different types of weighing balances, their principles, their advantages and limitations. We have also talked about how pH meter works, what is their working principle. We have also talked about magnetic stirrer. Now from there on we shall continue to discuss one of the most important and very crucial equipment which is used in any tissue culture lab. Today in this lecture we shall be talking about two very important equipments called as laminar flow equipment, also called as laminar airflow hood and autoclave. We shall talk about the general introduction about the equipments, how they look like, what is their working principle, what are their uses and what are their limitations. So laminar flow equipment is a primary control device which provides different kinds of services. With the help of laminar flow equipment we can have clean air to the critical sites which are immediate aseptic compounding areas. We can have constant airflow of air out of the work area to prevent the entry of room air, and we can also have an outward flow of air from the hood that suspends and removes contaminants which have been introduced in the work area. A typical laminar flow looks something like this, which we can see with the help of a picture, and the uses happens to be an individual clean air environment if it is required for smaller items such as particle sensitive electronic devices. It is used for special operations in laboratories also. Here is a picture of a typical laminar flow. This is a cabinet or a area under which the air is always maintained in a motion, and with the flow of air inside this chamber, this entire area is maintained contaminant free. These laminar flow, it can be tailor made to specific requirements of laboratories also, and are also used for general lab work, especially in medical, pharmaceutical, electronic and industrial sectors. A laminar airflow workstation is a closed cabinet fitted with HEPA filtered airflow system with unidirectional constant flow of air with almost no or minimal turbulence. The airflow velocity varies from 0.4 meter per second to 0.6 meter per second. The purpose of using such workstation in laboratory is to create particle and bacteria free working environment to carry out specialized work. HEPA filter is a particulate filter which traps the airborne particles and microbes, but it allows the gases to pass through. So HEPA filter should always be fitted either at or near to the clean room intel. A HEPA filter is fitted upstream of the HEPA filter, thus extending the final filter's life, and a fan is also fitted which pumps the air through the filter. So let us see this HEPA filter and the arrangement of filter with the help of a diagram. So this is a continuous sheet of filter medium which are separated by aluminum separators, and this is enclosed in a filter frame. So air always passes through this contortions of filter medium, and because of these fibers of the filters, the larger molecules, they are also stopped, and if only the small gases which are of very minute size, they are allowed by the process of diffusion. So after passing through this entire filter frame, the air is almost free from any kind of contamination, be it large dust particles or be it any thread or lint or any other microbial contamination. So what is a HEPA filter? HEPA stands for High Efficiency Particulate Air Filter, and it is the most important part of any laminar airflow hood. The air within the room is taken into this filter and it is passed through a pre-filter which removes the gross contaminants such as lint or dust, etc. After passing through the pre-filter, the air is then blown at a uniform velocity through the hood and HEPA filter in a unidirectional manner over the critical sites, which is immediate aseptic compounding area. So this unidirectional flow is all because of the unidirectional flow of the air, it is also termed as laminar flow because the air flows in a sheet arrangement in one direction. So there are two different types of laminar air flow which are very frequently used. One is called as vertical laminar airflow. It is the most used type of laminar airflow. In vertical flow cabinet, room air is entered in working area through HEPA filter fitted on top of the cabinet. Because of this arrangement of HEPA filter, the air flows downwards, or we can say vertically, towards the work surface and leaves the cabinet sweeping out particles and bacteria. These hoods in vertical laminar airflow, they sweep the filtered air vertically. The air passing through HEPA filter merges from the top and passes down through the working area. We can understand the construction of a vertical laminar flow cabinet with the help of this diagram, where we can see that this is a working table and this is the hood area. Now above this hood area there is a HEPA filter and then there is a blower, and above the blower is a filter pad, or here also lies a pre-filter. So because of this blower fan, the air is being sucked from above and this air passes through the pre-filter or the filter pad. Because of the presence of this filter pad or pre-filter, the dust and lint are stopped here only, and from this blower fan the air is passed through the HEPA filter and the direction of air is directly downwards, and thus it is the vertical direction of the air which gives the name vertical laminar flow cabinet. And this side is the working area from where any person would be working. So air directly gets blown from top vertically, and that's why this is called as vertical laminar flow cabinet. It is one of the most frequently used laminar flow. The vertical flow hood works on the principle that air flow between the HEPA filter and the component used for CSP's preparation should not be interrupted. When a foreign object comes in between sterile object and the HEPA filter, the wind turbulence in the critical area increases and the foreign contaminants are carried to the sterile work surface, thus contaminating the injection port, needle or syringe. So this is avoided. This is avoided through another type of airflow, that is your horizontal laminar airflow. So what is a horizontal laminar airflow? In horizontal airflow cabinet, room air is entered in working area through HEPA filter fitted on the back side of the cabinet. The filtered air flows horizontally towards the user, creating sterile working environment. These hoods sweep the filtered air from the back to the front of the hood. An electric blower draws the contaminated room air using a pre-filter, which is similar to a furnace filter, to remove gross contaminants. So a horizontal laminar flow cabinet can be understood with the help of this schematic diagram. So this is the working station, this is the working table, and this is the sterile hood or sterile area. In case of horizontal laminar flow, the blower fan sucks in air of the room from the filter pad or the pre-filter. So this pre-filter here takes air from this direction. The air comes and it is being sucked inside by the blower. The dust and lint, the gross contaminants, they are stopped here by the filter pad, and then the blower fan throws away air in this area, and from this chamber the air is moved horizontally on the working table on the sterile zone. So this direction of air flow is directly towards the person who is working. So because of this horizontal direction of airflow, this design of laminar flow cabinet is called as horizontal laminar flow cabinet. So how it works: the pre-filter demands timely cleanliness and replacement. The air after passing through the pre-filter is accelerated, but they are not pressurized, so that a consistent airflow distribution reaches the final filter, that is our HEPA filter, which is present at the back portion of the hood's working area. The HEPA filter removes 99.97% of 0.3 micron or larger sized particles, thus removing most of the 0.5 or larger size airborne microorganisms. So when the air is passed through HEPA filter, the sterile zone is almost free or almost sterilized from any microorganism which are of the size of 0.5 micron or a larger one. So this is a considerable amount of sterilization of the area, and whenever we work on a laminar flow, we intend to switch on this blower at least 30 minutes before we start the work, so that this horizontal flow or the vertical flow of air takes away all the previously occurring microorganisms. Before using laminar air flow, it is also sterilized. The inner surfaces are also sterilized with the help of any surface disinfectant such as isopropanol. Sometimes we also leave the entire inner area sterilized with the help of a UV tube light. So there are multiple layers of methods with which we sterilize that entire hood area, and whenever we work under this sterile area, we get a very good success rate in terms of contamination free transfer of biological materials. Now one such method by which we achieve highest degree of sterilization of any chemical or any equipment when we use in laboratory condition is called as an autoclave. So whenever we want to work on a live material, we want that there should be no external contamination affecting our sample or affecting our results. And to achieve that, we also need to ensure that our glasswares, our equipments, our chemicals, they are absolutely free from unwanted microorganism or any biological contaminant. And to achieve that, we treat them under a very high temperature and also at a very high pressure. Under high temperature and pressure, all the biomolecules get disintegrated or destabilized, and thus making our chemical or surface or any glassware absolutely free from any biological infection. So to achieve this, we use a very important instrument which is called as autoclave. So let us talk about autoclave now. So what is an autoclave? An autoclave is a machine that provides a physical method of sterilization by killing bacteria, viruses, or even spores present in the material put inside the vessel using steam under pressure. Autoclave sterilizes the materials by heating them up to a particular temperature for a specific period of time. So how an autoclave looks like? So an autoclave can come in various shapes and sizes. These are some of the examples of autoclaves. This is a vertical autoclave, this is a horizontal autoclave. The size varies from a small chamber to as large as a mini room. So an autoclave is also called a steam sterilizer that is commonly used in healthcare facilities and industries for various purposes. The autoclave is considered a more effective method of sterilization as it is based on moist heat sterilization. The simplest form of autoclave is the pressure cooker type or laboratory bench autoclaves. This is one of the simplest autoclave, also called as bench autoclave. Here we can see basic parts of an autoclave. This is the stand on which that entire structure is put. This is the autoclave body, and then on top of this, this is the autoclave lid. The autoclave lid has one safety valve. Whenever there is an excess pressure of vapor, it can be released through this. Then there is a pressure regulating valve, and then there is a pressure gauge. The pressure gauge gives us a real-time idea of the pressure which is being generated inside this autoclave chamber. And then there are two valves. One is called as steam releasing valve and the other one is called as vacuum releasing valve. So inside this autoclave, the water is boiled at a very high temperature because of the high pressure created, and under this high pressure and high temperature, all biomolecules, they disintegrate, killing all the bacteria, viruses, or maybe any other spores. This is a diagrammatic representation of a tabletop autoclave. So this is the bucket which is placed inside, and this is the stand on which this bucket is placed. The outer body is called the jacket, and our glasswares or the chemicals, they are put inside this bucket. On top of an autoclave lid, there are pressure gauze, then there is a safety valve, and then there are cover tightening nuts. So this is a basic schematic representation of a vertical autoclave. So how it works? The autoclave works on the principle of moist heat sterilization, where steam under pressure is used to sterilize the material present inside the chamber. The high pressure increases the boiling point of water and thus helps achieve a higher temperature of sterilization. Water usually boils at 100 degrees Celsius under normal atmospheric pressure or 1 atmospheric pressure, or at 760 mm of mercury. However, the boiling point of water increases if the pressure is to be increased. So this principle is employed in an autoclave where water boils at 121 degrees Celsius at the pressure of 15 psi or 775 millimeter of mercury. So the high pressure facilitates the rapid penetration of heat into deeper parts of the material, and moisture present in the steam causes the coagulation of proteins, causing an irreversible loss of function and activity of microbes. When this steam comes in contact with the surface, it kills the microbes by giving off the latent heat. As we all know that steam has, or water vapor has, a very high latent heat. The condensed liquid ensures the moist killing of microbes. Once the sterilization phase is completed, which depends on the level of contamination of material inside, the pressure is released from the inside of the chamber through the vessel. The pressure inside the chamber is then restored back to the ambient pressure while the components inside remain hot for some time. So, in general, an autoclave is run at a temperature of 121 degrees Celsius for at least 30 minutes by using saturated steam under at least 15 psi of pressure. So, this is a schematic diagram of how an autoclave functions. The various components are labeled here, and this is the internal chamber which has water. It gets heated up and very high pressure and temperature is created, and because of this very high temperature and pressure, any liquid or sample which is being kept here, it gets sterilized. So there are different types of autoclave. One most common happens to be the pressure cooker type or laboratory bench autoclave, also sometimes called as N type. These are they look like as domestic pressure cookers and are still in use they are still in use in many parts of the world. The more modern type has a metal chamber with a secure metal lid that can be fastened and sealed with a rubber gasket. It has an air and steam discharge tap, pressure gauge and safety valve. There is an electric immersion heater at the bottom of the chamber. Now the second type of autoclave is called as gravity displacement type autoclave. This is the common type of autoclave used in laboratories and are comparatively cheaper. In this type of autoclave, the steam is created inside the chamber via the heating unit, which then moves around the chamber for sterilization. This is the diagrammatic scheme where we can see that the steam is supplied, which enters into the chamber, and the steam sterilizes, and the cold steam then comes out with the help of a valve outlet. Then the other type of autoclave happens to be positive pressure displacement type. In this type of autoclave, the steam is generated in a separate steam generator, which is then passed into the autoclave. This autoclave is faster as the steam can be generated within seconds. This type of autoclave is an improvement over the gravity displacement type. And then there is a negative pressure displacement type. This is another type of autoclave that contains both the steam generator as well as a vacuum generator. So the vacuum generator pulls out all the air from inside the autoclave, while the steam generator creates the steam. The steam is then passed into the autoclave. So these are different types of autoclave which we have just discussed. In our next coming series of basic laboratory equipments, we'll talk about spectrophotometer. We shall also talk about SDS page, gel electrophoresis unit and other equipments. I hope I have been able to give you a basic, fairly good idea about the functioning and uses of these basic instruments which we use in our laboratory. Thank you so much for your patient listening.